Hey guys, in this video we're going to talk about geometric proofs. We're going to prove the postulates side side side, side angle side, angle side angle, angle angle side, and HL. But first we have to cover a couple of definitions. The main definition we're going to focus on in this video is the reflexive property. The reflexive property is very powerful. It has properties in both geometry and algebra and is used in almost every discipline of math. And the reason for that is because every discipline of math has proofs as part of it. So in other words, how do these math disciplines come to conclusions? They come to conclusions through proving, which is something that most of us do not do at the elementary and even the intermediate levels of math. So let's take a look at what the reflexive property means. Essentially, all it means is something that is congruent to itself or equal to itself. Most clearly for most of us would be here. So this is an algebraic or arithmetic example of reflexive, where both sides are exactly the same. In this case, we're going to be focusing on the geometry version. So, we don't really come up with reflexive angles too much in congruency proofs, but this would be a reflexive angle. So, we would make a statement something like angle, I guess I could say GDF is congruent to angle GDF. This is the type of statements you make to show that something is congruent to itself. Same thing for this side here, which is what we're mainly going to see in these proofs, is that this middle altitude here, this is an altitude of this triangle, and we're going to be able to say, I didn't put a point here, so I'll put D there, and I'm just going to say something like AD is congruent to AD, something like that. And that's a reflexive statement, or a statement saying that both triangles share the same side and it's reflexive to itself. Alright, let's get started on our examples. So we're going to start with side, side, side. Side, side, side is a postulate. What a postulate is just a theorem or a theory that's been proven true, and you could use it as a definition. In this case, what we want to say is that if I could prove that two triangles have three congruent sides, or three pairs of congruent sides, then those triangles are themselves congruent. So let's get started. Just like in my previous videos of proofs, you always have to copy the given down word for word. The first step in understanding a proof is understanding what the proof is providing you and what you want to prove. As mentioned in my previous video, I always write the givens down and get that off my plate before I even start to consider the proof. So in this case, it gave me AC is congruent to AB. Congruent is that equal sign with a mustache here. That means congruent. And what it essentially means is that those two lines are the same in every way, physically. Equality is a numerical concept. So because we don't have any measures here, we can't use numbers or a numerical value. So we have to physically say that they're the same. Now, from there, it says that AC and AB are the same. The typical way to mark this off is to place a hash mark on those lines. That indicates that those two sides, or those two lines, are congruent. Now, it also gives me that CD is congruent to DB. Well, that would be these two sides here. The way I mark it off is I give it two hash marks. All I'm indicating is that CD is congruent to DB, but it is not the same as AC is congruent to AB. And typically all you do is just pile up the hash marks as you find new sides. In this case, will always be limited to 3 because we just need 3 parts to prove the triangle is congruent. Now I'm going to use the reflexive definition. So I see here that AD is cutting this triangle in half. So that is shared between both triangles, and I'm going to call that a reflexive side. The way I make that statement is I say AD is congruent to line AD, and that is the reflexive property. So we just write that out. Oftentimes, you will see a definition added to these proofs for reflexive property, or I'll say reflexive property of congruence or equality. For the sake of these proofs and because we're beginners, we're just going to stick with reflexive property, or if you like, congruent to itself is all we're saying here. So now let's take a look at what we have. As a beginner prover, I highly recommend that you use your diagram. So I'm going to label off what I have. Well, AC is a side, and so is AB. So that's a side of both triangles. CD and DB are sides of both triangles. And then I have my reflexive side. As you can see, the side postulate spells itself out in the diagram. So I can now make the conclusion that triangle CAD is congruent to triangle BAD because of side congruency or side postulate. However you want to write it. It's often just written SSS, and then maybe a definition attached to it. One more thing I want to show you before we move on. When doing these proofs, it's really helpful to almost do an inventory of all the parts you have that prove your triangle congruent. So, if you notice here, I have all 3 sides listed. So these are all sides. Once again, proving and spelling out my postulate. Alright, let's do the next example. Alright, I'm going to move along a little bit quicker here because all we're doing is giving examples of the postulates and what they would look like. So I wrote down my given, and now what I'm going to do is mark off my sides and parts. I reiterate, it is very critical to take the time to read the given and understand what it says. If you can't understand what the given is saying to you, then you cannot do the proof. So here it's saying angle CAD is congruent to angle BAD. Well, the way we read that is, I start at angle point C, then trace that up to A. Hopefully this highlighter is going to help. And this angle here in the middle where A is, that is my angle that I'm talking about. So angle CAD is referring to this angle here. BAD is on the other side. So again, I start off with B, then trace my angle up. There's my vertex in the center, and then chase it back down, and that is that angle. One of the biggest challenges for students when it comes to proofs is learning to read your angles. Now, from there I have an angle, and the second part of the given gives me the sides, CA and BA. CA is referring to this side here, and BA is referring to this side. From there, I'm going to once again use my reflexive property definition, which is AD. So I'm going to make the statement that AD is congruent to line AD, and that is the reflexive property. Now what I'm going to do is I am going to take an inventory of the parts I have So I could see if I have enough to show the side angle side postulate. AC or CA as listed in the given is a side. Angle CAD is an angle, and then I have my reflexive side here. On the other side, I have the same thing going on, the other half of the triangle. To state that better, BA is a side, angle BAD is an angle, then AD is yet another side. So it spells out side, angle, side. I can conclusively state that triangle CAD is congruent to triangle BAD by side, angle, side. Now the last thing I'm going to do with this proof is I'm going to take a moment and just do an inventory of my parts to make sure I've listed everything that proves my triangle is congruent. Well, I have an angle here, and then I have a side and a side here. So I have all the parts listed. Focus on the diagram. The diagram will spell it out for you. But here you have to make sure you list out all of your parts to have a proper proof. Let's try the next example. In proving angle side angle, this is where labeling your diagram pays off in dividends. So first I'm going to label the first set of angles, CAD, as I did earlier, and BAD. And now I'm going to label the second set of angles. So in this case, CD, which happens to be a right angle, A, and BDA. Okay, those angles are congruent. Now I'm going to use my reflexive side property that I've used in the previous two examples, and I once again have line AD is congruent to line AD via the reflexive property. Okay, now let's take an inventory on my diagram to make sure I have angle side angle. So this is an angle, this is a side, and this is an angle. And once again, notice how it spells itself out. I think that this is a critical step in making sure you have everything in accordance to a complete proof. Again, the lines themselves do not need to be in order. In fact, this is a different postulate if you just look at the table. You need to use the diagram. So now I can conclude this proof. Okay, so what I've done here is I've proven that these two triangles are the same on both sides of, let's say, the larger triangle, using the fact that I have two pairs of angles that are congruent with a pair of sides in between them, or the other word that's often used is included. That shows that the triangles are the same. Alright, let's take a look at the next example. So in this example, I chose to write the given on one line, which you could do to conserve space. So I wrote the both angles together. Again, as mentioned in my previous example, marking up the diagram pays in dividends here. So let's get started. Angle CAD is up here. Just focus on that middle letter. And in the other two letters give the direction. Angle BAD is here. Then we have DCA, which is here. And DBA, which is here. Take some time to practice that. Make sure you're carefully paying attention to which angles are what. Now I'm going to employ the reflexive property, which again will be line AD is congruent to line AD, and that's the reflexive property. From there, I am going to take an inventory of what I have on the diagram. So I have an angle here, an angle, and notice that the side is not in between them. So this would be angle side angle, but we don't have that. Then here I have angle over here, an angle over here, then a side. So this time it spells out angle, side angle. And I'm going to just take my inventory on my table and just make sure that I have it all together, which I do. And now I can write my conclusive statement, which is that triangle CAD is congruent to triangle BAD using the angle, side postulate. In other words, I have two pairs of congruent angles and then one pair of congruent sides outside that force the triangles to be congruent. Alright, let's take a look at the last example. So for this example, we want to prove the triangles are congruent using hypotenuse leg. There's a couple of limitations that we need to discuss. So the given in this proof provides the fact that I have two right angles here. I have to decide how I'm going to use those right angles. So here's the limitation. Hypotenuse leg can only be used with right triangles. So I have to declare that I have a right triangle. On the other hand, a right triangle can be used in all of the other postulates, but in that case I do not need to prove that I have a right triangle, only with hypotenuse leg. So let's get started on what that looks like before I use the second part of the given. I'm going to make the statement that the triangle CAD and triangle BAD are right triangles. And the reason for that is the given. So I am going to literally write the words in the given as my reason. There are a number of ways to achieve this. But for us beginner provers, what I'm going to insist on is that you just use the information in the given. So oftentimes in more formal proofs, we see the definition of a right triangle or some kind of other axiom posted in the reason, which is derived from the given. But if you're a beginner, just use the language that was given to you to support your statement. Okay, let's go with the second part of the given. This is another good example to state that you could really write the given when you want. It is wise just to copy it down right from the start. But if you want to use the given in different parts of your proof, you could totally do so. And in this case, I'm just stating the given, which is CA and BA are congruent, which in this case are the hypotenuse of this triangle. The hypotenuse is the side across from the right angle, and it is also the longest side of a right triangle. So from there, I already have the hypotenuse. Now what I'm going to do is use the reflexive side to get the leg. All a leg of a right triangle is the sides of the right triangle other than the hypotenuse. So I now have evidence that I have a hypotenuse and a leg congruent. Here are the legs. So now that I've taken an inventory of these things, I can now just make sure it's written in the table, and then I can make my conclusive statement. Every postulate requires three parts. So in this case, even though it looks like I only used two, first I had to show that my triangles were right triangles by applying the fact that they have perpendicular sides. Then I had to discover congruent hypotenuse and congruent legs. So those are my three parts. Again, I reiterate, as I have so for 4 times, make sure to use your diagram to help navigate which postulate you're using. So now that I have everything listed, I can make my final conclusion, which is that triangle CAD is congruent to triangle BAD, and that is because of the hypotenuse, if I could spell it, there we go, hypotenuse leg postulate. These proofs are a little bit more difficult than the previous ones. They're very investigative in nature, and they could take you a long time to find the little details to get you where you need to be. It often is helpful to come up with what you think a conclusion could be, then from there come up with a strategy to prove that conclusion and try to get there. But as I've shown in my previous proof videos, that sometimes the conclusion we start with is not the conclusion we end with. Okay guys, I hope you guys have found this video helpful.